Hi everyone, welcome to my channel. As you can see, I've added some components to the I2C temperature sensor circuit from the last video. I've added a shift register, an 8-bit shift register, and 8 LEDs that are going to give us a visual representation of the temperature in the form of an LED bar graph. Let me turn this on. And you can see there, first LED is lit, and I have a hair dryer here. Let me warm up the temperature sensor a little bit. And the LED should progress as the temperature increases. We have 4 green and 3 yellow and 1 red to indicate the highest temperature. See if we can get there. And there it is, red. And as that cools down, the LED should start turning off one at a time. See how long that takes to cool off. I can speed that up by spraying it with some canned air upside down there to get the cold, I don't know what there's in here, Freon or something. Oh, that jumped right down. So you can see there, that measures temperature and gives you a visual representation with these 8 LEDs. Wow, that really jumped down quickly, didn't it? That's cold. So there are some interesting concepts in this experiment and a lot of similarities between lighting these LEDs in the bar graph and these scanning LEDs, sort of the Knight Rider effect, in another video that I posted. Let's take a look how we get these LEDs to light as a visual representation of the temperature from this I2C temperature sensor, digital temperature sensor. So basically we're taking the direct temperature from this digital temperature sensor in degrees Celsius, and we're converting that into a binary representation, or 8 bits that get shifted into the shift register to turn on the LEDs. So as you can see, we progressively turn on these LEDs. We don't turn on one at a time. We turn on the first one, and as the temperature increases, that one remains on, and then we turn on the next LED, and so on, to give the visual representation of the temperature increasing up this bar graph. So we have to shift in an 8-bit word, or 8 bits, to turn on these LEDs in this pattern. So let me explain this using the whiteboard. So here are the 8 LEDs, 1 through 8. We've got the 4 green, 3 yellow, and 1 red. So this is a representation of it. This is what it looks like. So we have this LED turns on at one temperature, and then as the temperature increases, we leave that LED on and turn on the next LED, and so forth, and it slowly progresses as the temperature increases. So as the temperature increases, we're going to turn on more and more of these LEDs in this progression here, right? Until the highest temperature, where we have all 8 LEDs turned on. So how do we do that? Well, we convert the degrees Celsius into a binary representation And that binary, or 8 bits, get shifted into the shift register to turn on the appropriate LEDs. So this is similar again to the video I did on the scanning LEDs. So we have a 1 in binary would just be all zeros and a 1, right? And then the 3 is a 1, 1 in binary. 7 in decimal is 1, 1, 1 in binary. 15 is 4 ones in binary. 31 is 1, 2, 3, 4, 5 ones in binary. 63, 6 ones. 127, 7 ones. And 255 is 8 ones. So when this binary number of 8 ones gets shifted into the shift register, it will turn on, that's the highest temperature sensor reading, it'll turn on all 8 of these LEDs. So I've tried to summarize the relationship between all the numbers that we're manipulating or going to manipulate in the program. Sort of a summary, and this is what it looks like. So we have these decimal numbers which have these binary representations, and we have to pick a range of temperatures. The IC2 temperature sensor has a larger range of temperature measuring capability than we're going to take advantage of. We're only going to use 8 LEDs, so we have to pick a range of temperatures of interest, and we're going to use 24 degrees C up to 31 degrees C. That's 8 discrete temperatures, and those are the only ones that we're going to be concerned about and represent in the visual representation with the LED bar graph. And so we then have to take all these numbers and associate them with each other in the program. And the 24 to 31 degree temperature range, which we're going to measure, is associated with 0 to 7 LEDs, or 8 LEDs. So we've got 4 green, we've got 3 yellow, and the highest temperature is going to be red. So if we just pick the highest temperature, we're going to have a decimal number we're going to manipulate, 255, which is translated into 8 ones, which is also going to be representative of a 31 degree temperature reading, and it's going to light the red LED in addition to all these previous LEDs are going to remain lit. So somehow in the program we have to bring all this together, all these associations. So let's take a look at the program. So here I've summarized the important code in this sketch that's been added to the previous sketch that's going to bring together all those relationships between the LEDs and the temperature we're measuring. So we start off by creating an array, and the array is going to have all those decimal numbers that will give us the right combination of LEDs being lit from 1 to 255. Remember, those are the numbers that will light the LEDs in the bar graph representation that we want. Right? Now internally they're going to be in binary form. Right? So now we have a variable, an integer variable we're calling graph, and what we're going to do is this C is the actual measurement that we're receiving from the digital temperature sensor. And this is the range that we're going to remap. This physical number is going to be constrained sort of between 24 and 31. That's the range that we're only interested in. And then we're going to take this range and change it from 24 to 31 to 0 to 7. So the temperatures from 24 to 31 are going to get changed to a range of 0 to 7. And then that's going to be stored in this variable graph. So map remaps a number from one range to another. Then we're going to make sure that we're constrained to 0 to 7 by using this constrained function. So we're going to constrain the number graph from a range of 0 to 7 to make sure we're in this 0 to 7 range. Now the number that gets stored in graph, this is going to point, this is the number we use to point to these elements in our array. So this will return a number from 0 to 7. Now remember, the elements in an array are 0 indexed. So this is element 0, 1, 2, 3, 4, 5, 6, and 7. So if graph is equal to 0, it's going to point to this element, which is a 1. And that 1 is going to be this in binary. And this will get shifted into the shift register to turn on the appropriate LED. And if graph gets returned a number 7, so if graph is equal to 7, it's going to return this number here. It's going to be pointing to this element 255, and 255 is going to, binary representation is 8 ones, and this will get shifted into the shift register to turn on the appropriate LEDs. Well, in this case, all 8 LEDs. Another thing we have to keep in mind is if this is the 8-bit shift register, we want to if we're shifting in this direction here, we want to shift in the first bit we want to shift in the most significant bit first, right? Because that'll get shifted down to here. So if our temperature is returning a 1, right? If the graph is returning a number 1, or it's pointing to element 0 in the array, we only want this one turned on. So all these zeros have to be shifted in first to finally get this to light. So if we had, 0, let's see, 1, 2, 3, 4, 5, 6, 7, 8. This here gets shifted in first. So we end up with 0, 0, 0, 0, 0, 0, 0, 1. So it starts, this is the most significant bit, and this is the least significant bit. So we start at this end, and then these get shifted into the shift register, and then they get shifted out to the LEDs, so it'll light this LED. So let's take a quick look at the program, the complete program. So like the previous program, we have to start by importing the wire.h library. So we have include wire.h. It's the same as the last sketch. And here we set up the variables for the shift register. We have SER for serial output to the shift register. That's going to be pin 8 from the Arduino. Constant integer latch, pin 9. It's a shift register latch pin. And constant integer clock, pin 10. And that's where we get the clock pulse to the shift register. And from the last sketch, we know that the temperature sensor has an address of 72 for the particular one that I have. So here we start the array. So here we set up the array. It's going to have 8 elements, and these are the elements in the array. Now remember, depending on which one of these elements we use, you get the progression of the LEDs on the LED bar lighting up. So at the extremes here we have one LED, and at the other end we'll have all the LEDs on, because 255 in binary is 8 ones. Now we set up the serial port communication just like before. So here we have wire.begin. We create the wire object, and here we specify the pins as output on the Arduino. We have pin mode, SER is an output, pin mode latch is an output, pin mode clock is an output from the Arduino. Now here we start communication with the temperature sensor. We have wire.begin transmission at address 72, but remember there's 2 registers in that temperature sensor, so we have to point to register 0 that contains the temperature data, and we're going to write a 0, and then we complete transmission by wire.end transmission function. And like in the last sketch, we're going to read the temperature now, request 1 byte from the specified address, wire.request from this address, and 1 byte of information. We've got wait for response, and then once we have an acknowledgement, we're going to take and use wire.read and read that temperature into the variable C. It's an integer variable. And now we're going to map the temperatures to the LED settings. So remember, we have this array with 8 elements, and depending on which one of these decimal numbers we shift into the register will give us that progression on the LED bar graph as the temperature increases. So we have this map function here. It's going to take the temperature C, and we're going to take the range from 24 to 31, which we've decided to use. You can change this if you want. And we're going to remap this to a range of 0 to 7. And to make sure we're in that range of 0 to 7, we're going to use this constrain function, which is going to take the value in graph and constrain it to values of 0 to 7. Now we're going to start shifting that information into the shift register. So we have a digital write latch low, which then enables us to shift information into the shift register. So now we have shift out, serial clock is a shift out function. We have to give it serial clock, and we want to say the most significant bit. Remember, we want the most significant bit shifted in first, and then we take this is how we point to one of the elements, one of the 8 elements in the array. We have vals and graph. Remember, graph is going to be a value from 0 to 7. So vals is an array, so depending on what number is in here, 0 through 7, that will point at one of these elements in the array, which are 0 index again, remember? So 0 through 7. So if we return, if graph has a value of 7, we're then going to point to this element in the vals array, and that's the number that will get shifted into the shift register. So that's what's accomplished with this line here. Then significant bit, most significant bit first, we've got digital write latch high, stop sending data. So once the latch returns high again, we stop sending the data. And then this is the same, where if we look at the monitor, serial monitor program, we're still going to be able to see the temperature in degrees C and degrees Fahrenheit, and print that out in the monitor program. The only thing here is that if we look at the serial monitor program, we're going to be able to see the temperatures that are outside of the 24 to 31 range. This constrains the bar graph to these temperatures, but of course we're not constraining the temperature sensor itself. The temperature sensor has a lot wider range than the 24 to 31 degrees Celsius. This is the constraint just because we only have 8 LEDs and we want to pick units that can fall within a range of visually using 8 LEDs. If we increased this range, so there was a larger range of values, we could then use more than one shift register and double up and end up having, instead of 8 LEDs, 16 LEDs. That way the units would be smaller, and visually it would tell you that you have a wider range of temperatures that you're keeping track of with the LEDs. So again, to summarize, we start off, we have an array of 8 elements that we create called integer vals. 8 elements again, and those elements consist of these 8 different decimal numbers, and each one of these decimal numbers is a progression on the LEDs. If you look at them decimal wise, they have ones that progress until we get up to 255, which has 8 ones, and then that lights up the LEDs to give us that visual LED bar graph. We take the temperature we're actually measuring from the digital temperature sensor. We're constraining that. We're only interested in temperature range of 24 to 31. And we remap that to a value of 0 to 7. And this 0 to 7 is going to point to the element 0 to 7 in this array. Remember, the array is 0 indexed, so this is 0 element all the way up to element 7. And then to make sure that we're only have elements 0 through 7, we constrain this value of graph to 0 to 7 using this constrain function. So I hope that's given you an understanding of how this circuit and how this program works. Let's hook it up again. So I hope you found this video interesting. Feel free to subscribe, like, and/or comment. And thanks for watching. Let me get the hairdryer.